physics, we have the lecture of the circuit. So I will start from the basic introduction of the circuit. A circuit is a closed loop that allows current to flow, often from a power source like a battery, and through the various components like resistor, capacitor, and then back to the power source. This is like a closed circuit. As the current is starting from the one point, then it is going back to the previous point, because this is the definition of current is flowing. What is the definition of the current? That current is flowing in a closed loop from one point to another. Charges, electrons. Is that clear? Yes. And the continuous flow of electrons constitute an electric circuit. So basically this is a circuit in which all the electrons are like continuously flowing in the circuit and they are just generating electric current. For example, when you put आपके सामने भी जो ग्राफ बना हुआ है ना, वो सिंपल ग्राफ है दो चीज़ों के दरमियान. किस किस के दरमियान है? बैटरी और वायर के दरमियान है. ऐसा ही है. This is a graph only between the wire and the cell. There is no other thing. This is only two components. When we have these two components, the graph is closed. Current is flowing from the positive. Can you tell me which one is positive, which one is negative from the cell?
Let's say line is positive, longer one is negative.
Longer one is positive, smaller one is negative. Longer one is positive, smaller one is negative. Remember these two things, okay? And when you have to... Yes.
No current will transfer from negative to positive.
Yes, this is a question also, like when current travel from the positive terminal to negative terminal, what that current called, and when the current travel from negative to the positive, what that current will be called. Do you have any idea about these two currents? These two currents have the different names. Any idea?
No idea.
Okay, I will tell you. When the current travels from the positive terminal to the negative terminal of the power source, it is referred to as a conventional current. Now you have to open your register. You have to mention today's lecture name, introduction. Okay, this is clear in the PDF that this is the introduction to circuit. Okay, then you have to draw this circuit. Then you have to write the definition of the circuit. Any closed loop in which current is continuously flowing. Okay. First, you have to mention the topic is introduction to circuit.
Yes.
And then you have to write it like in the bold form, circuit, like this, circuit. And then you have to write the definition of the circuit. Done? A definition. The definition of the circuit is closed loop in which current is continuously flowing. Okay. Now you have to draw the circuit as well. No. I will explain it to you according to the components. Okay, you just have to write one thing. I am done with the definition of the circuit. Okay, one thing. You have to mention the heading conventional current. Conventional current. Put the heading conventional current. Do you know the spelling of conventional?
Yes.
Okay, very good. Put the heading conventional current. Done? Listen carefully. When current, I will explain to you with the help of this graph. Okay, then you have to write and listen. When the current travels from, this is the positive, this is the negative. When the current travels from positive terminal of the source towards the negative terminal, this is known as conventional current. Okay. Basically, this is an opposite flow. Always in a circuit, current is always generated from the negative terminal. Why? Do you have any idea in the current why there is an opposite? It's just like an opposite flow. We generated that, but basically in the circuit, current start flowing from the negative terminal? Why? Can you give me any solid reason? One reason. Why?
Current
Can you tell me the current that is flowing in the circuit? It is because of the charges. Every charge has electron. Electron has the charge positive or negative? Negative. So current contains charge. Charge has electron and electrons are negative. So current is generated from the negative terminal. Okay?
So we can also use this word for heat as well. Like, for example, like you can say that a convectional current is being formed in some type of liquid in which the heat is going from top to bottom.
Yes, we can say this. We can say this. For example, when you have a wooden spoon, and half of the face of the spoon you put in the top of the stove, heating stove. Okay, it start heating. Maybe if you put it from the positive, that doesn't matter. If you put it from the negative, it will transfer the current. It will transfer the heat. For example, if the water is flowing from height and to the ground, same it is जब हमारे घरों में घर के टॉवर पे छत पे क्या रखी जाती हैं पानी फिल करने वाली टंकी रखी जाती है ना टैंक रखा जाता है जब वो फिल हो जाता है तो देखिए कितनी हाइट से नीचे गिरता है और आप कहते हैं मामा मोटर बंद कर दे टंकी फिल हो गई है ऐसा ही होता है ना तो वो हाइट से गिर रही होती है ना तो यही चीज़ें हमें बेसिकली पता चलती हैं अब करंट में क्या अब करंट में सर्किट में ना देयर इज नो हाइट देयर इज नॉट अ कॉन्सेप्ट ऑफ अ हाइट देयर इज अ कॉन्सेप्ट ऑफ अ सोर्स देयर इज अ कॉन्सेप्ट ऑफ द चार्जेस देयर इज अ कॉन्सेप्ट ऑफ इलेक्ट्रॉन फ्लो okay so what is the concept of electron flow when the positive charges is moving from the charges the current is moving from positive to negative that is known as conventional current okay so basically this is an opposite thing this is an opposite flow of current but the universal fact always in a circuit current starts flowing from the negative terminal now you have to put the heading electron flow after conventional current put the heading electron flow this is the flow of current in a circuit which is known as electron flow which is moving from negative to positive got it till this I hope you get the idea do you have any question Ayan
No.
not yet
No.
good so now you get the idea that in a circuit current travels in a both direction but when it travels from positive to negative we name them as conventional when it travels from negative to positive we call it as electron flow got it now I will start the proper lecture if you face difficulty if you want to get more idea about any component any topic you can just stop me at there and ask me the question okay so I will start so today we are going to take a look at the what circuits are and how we can draw them with a couple simple components we also explore the terms potential difference when you put a source this is a source from which current is generating in the circuit this is the two endpoints of positive and negative this is also known as a potential difference this is also known as potential difference and the voltage both are the same things okay so we will discover the three different components like the potential difference current and the resistance when you have to use these components in the circuit they have the way of representation okay as you can see here can you tell me what is this Ayan this one very good and then next one battery in the source and the next one
Switch.
very good switch now I hope till this you get the idea something for electrons to flow through okay
Yes.
Okay, a circuit current flows on electrical circuit is just a closed loop that contains a power source, such as a cell as shown in the figure, and something for the electron to flow through like this a wire. Because cell is a source from which electrons are generating and they're continuously moving inside the circuit. Got it?
Yeah.
And we generally represent them with a circuit diagram, and this is here the probably the simplest type of a circuit you ever see in order to draw more complex circuits. Don't ever think this is the only basic diagram of the circuit. Don't ever try to think, because when I was in my bachelor's degree I have studied the whole book of the circuits, electro circuits, and that kind of circuit is just like a very weird things. It becomes very difficult for a single student, because even we have to draw them, even we have to explain them, and even we have to connect them as well, because there are like too many wires connecting on the single term that things become very difficult for us, every individual student there. So in your topic this is not that much difficult. It is a very bit easy thing. Okay. And in order to draw more complex circuit, we just need to know these symbols for the different components and where to place them. This is a very important thing. Okay. The basic concept is that where we have to place the lamp, where we have to place the source, where we have to place the switch. Okay. And
Yes.
then next, yes.
I was just asking.
Okay. Do you have any question? Okay.
No.
Okay, now they add one thing, that is a filament lamp. What does that mean by filament lamp? Why they didn't just call a simple lamp?
Because there are many different types of lamps.
Lamp. Yes. Have you ever experienced that in the previous days, like if we just go back to 10 to 15 years, we have that kind of yellow bulbs in our houses. Now we have the light bulbs, no? Yellow bulbs. That is like a round shape and yellow. And some कुछ बच्चों की बहुत बुरी आदत होती, जब भी घर में वो ख़राब हो जाता था, हमारे पेरेंट्स उसको सिक्योर करके कहीं रखते थे कि चलो ये कहीं ना कहीं काम आ जाएगा. ख़राब हो जाता है लेकिन उसको संभाल के रखते थे या फेंक देते थे. बट वो येलो कलर का लैंप होता है जिसकी येलो कलर की लाइट. अभी तो ये सिंपल बल्ब होते हैं ना जो वाइट कलर के होते हैं, वो येलो कलर के बल्ब होते थे. उसको तोड़ के अगर आपने कभी देखा ना, उसके अंदर 3 बिल्कुल बारीक बारीक वायर्स होती थी. उन वायर्स को कनेक्ट करने के लिए बीच में स्प्रिंग लगा होता था. दैट इज़ द फिलामेंट. क्योंकि वो क्या होता था, वो जब बल्ब कैसे काम करता है ना, वो भी मैं आपको किसी दिन एक्सप्लेन करूँगी. दिस इज अ फिलामेंट लैम्प जिसको 1 by 1 जी
by getting intense heat.
Yes, and then that bulb just get the electrons one by one, it gets heat up and it just blow up. Okay, small light bulb होता है. I think आपने ये practical किया स्कूल में. Have you ever done this?
I think so that a lot. But I haven't done it.
Okay. Okay, now they add the filament lamp. Now this is a switch. Now they add the switch. This is a circuit that is with on, a bulb is on because switch is closed. This is the diagram when switch is closed. Okay. So the batteries are made up of 2 or more cells and their symbol is just 2 cell symbols put together. And although as far as example are concerned, cells and batteries both act in the same way. Even you can write cell and battery. Don't get yourself confused between the battery and the cell. Okay. Okay. So we could also add a switch which could be closed, allowing a current to continue flowing around the circuit, or open, which would disrupt our circuit and so turn off our light. Even if you want to like close the circuit, you can just open the switch and the current flowing will be stopped. Okay.
Okay.
And now we have to understood the concept of, now switch is open, and in the previous picture the picture is yellow because of the bulb on, and our bulb is off and the switch is off. Okay. Now we have to, like the key term, we have to get the idea what is the potential difference in the circuit, what is the current, and what is the resistance. Okay. Before starting that, I just wanted to hear the basic ideas of these 3 things from you. potential difference.
So you want
And define potential difference, current and resistance according to the concept of a circuit.
potential difference
Hmm.
it is the work done on unit charge throughout the circuit.
Okay. So what is another name, another term used for the potential difference sometimes?
Voltage.
Very good. Voltage. Voltage means that is telling us how many volt of current is moving in this circuit. That is the potential difference. Okay. In which unit potential difference measured?
Volts.
Very good. Volts. And explanation according to the circuit.
That the voltage measures how much the current is being flowed in the circuit.
Okay. So potential difference is produced between 2 points. What are that 2 points?
Between the negative.
Very good. Very good. Okay. Now tell me the basic idea of the current.
Current is the flow of electrons throughout the circuit.
Very good. Flow of electrons or flow of electric charges. In which unit current is measured?
Amperes.
And then you just give me the explanation of the current according to the circuit. What do you think about the resistance?
Resistance is the opposite or flow of electrons.
Yes, that oppose the flow of the current. For example, if current is coming from the minus to plus, when you put the resistor, it will oppose the flow of the current. It just start flowing from positive to negative. Okay. And in which unit resistance is measured?
Ohms.
Very good. Now, I think you know much better things before explaining me. Okay? Because अगर मैं explain करूँ भी तो आपको तो उससे पहले ही इतना अच्छा idea है. हर एक चीज़ बहुत अच्छे तरीके से clear है. ठीक है? Okay. So the potential difference. Potential difference specifically potential difference current and the resistance. Current denoted by the letter I and is measured of the flow of electrons around the circuit. And similar to the flow of the water through the pipe. For example, if we have a more pressure of the water, we have the more pressure of the current. If there is less pressure, there will be the less current. Okay? And it is measured in ampere, which we often just call amps or denoted with the letter A. Meanwhile, a potential difference denoted by the V, small v, okay, and is the force driving this flow of electron and is provided by the cell law battery. You can think of this as the pump that forces the water along the pipe. For example, this is just like a water that is coming from the pipe. Now when we have pump, when we have a tap, when we open that, we just giving a force that water just, you have to come out of from that. You have to come out of from that. Okay. And it is measured in volts. Finally, resistance is exactly what the name suggests. It's everything that resists or opposes the flow of electron, similar to the partial blockage in our pipe example. For example, if we put a blockage, that is the water that is coming from the pipe. When we put the blockage, it will change its direction, the flow of direction. Okay. And the last thing we need to cover is which the way around the circuit current flows. If you look at the cell on this circuit diagram, okay, one shorter line and the longer line is cell or battery is always the positive terminal, and whereas the shorter line is always the negative terminal. Now, because electrons are negatively charged, they flow around the circuit and from the negative terminal to the positive terminal. However, when some people first discovered electricity, they did not know anything about this. When the scientists discovered about the concept of electricity, they don't have any idea about how is current is flowing and where is current is flowing. They just get the idea about the charge and the current, okay? And now we keep this conventional, sometimes calling it a conventional current from positive to the negative. So even though it's a bit weird, just remember that for your exams, current always from the positive terminal to the negative terminal for your exams point of view, okay? That's positive terminal to the negative terminal, that is a conventional current. But as electrons are negative, so it's generated from the negative terminal. But for your exam, according to your book course, you have to remember the concept of the conventional current. Did you get all the points? Okay. Do you have any question? I think you don't have. So far, so good? Okay, now we have to do the series circuit. So let's just give a little bit idea about the series circuit. Series circuit is a type of electrical circuit in which components are connected end to end, one after another, like forming a single path for electrical current. By looking at this picture, you can see that this is a diagram of a parallel, this is a series. So this is the basic diagram of series. You can see this. This is a 2 lamps. That doesn't matter how many lamps you will adjust in the circuit. That is the basic concept, okay? In a single wire, only 1 lamp will be adjusted. Have you ever seen that on a 2 wire, on a 1 wire, we can place 3 to 4 lamps? We can? No, of course not. Can I place a lamp here? 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 No. On every single wire, I have to place only 1 lamp. Is it? Yes. We cannot place so many lamps in a single wire. Okay? So, this is an idea. And the current that flows through each component is the same. This lamp is getting a same current. And this lamp is also getting the same current. Why they both are getting the same current, Ayan? Just take your time and just give me the answer. Why these both lamps are getting the same current?
Maybe
a switch or a lamp, okay? So if I place a switch here, okay, if I turn on, then the current will start flowing. If I off, then current will stop for both of them switches. ऐसा नहीं होगा कि अगर एक मैंने स्विच ऑफ कर दिया तो एक बल्ब ऑन होगा दूसरा ऑफ होगा, नहीं, सारे के सारे इकट्ठे ऑफ होंगे एंड देन इकट्ठे ऑन होंगे स्विच ऑन या ऑफ करने से. क्लियर? Okay, so this is the basic concept of the series circuit. So next thing is in a series circuit we only have a single loop and the components are all connected one after the other, and this small difference completely change how we can measure a current, voltage and resistance. So let's just talk about the potential difference. As I told you about, this is a formula I'm talking about, that very few things are connected in series. Very few things. Do you know this? How many few things can only connected in series? Like only the bulb. Yes, only the bulb. Like the source. And then potential difference. And then current. Is it? Only these few things can connected in this series circuit. So this is the formula I'm talking about, the potential difference of the battery. So basically this bulb is getting its own potential difference and this bulb is getting its own potential difference. They both have their different, okay? But the current, I will mention this has the V1 potential, this has the V2. And if I place another one, this will be the V3. Got it?
yes.
And this is the source. This is, and so we can say this is a cell. So the current that is coming here, that is I, And the current that is coming here, that is also the I. Both are the similar, na? Same currents. Got it?
Yes.
Okay. So this is a formula. You have to write it down, Ayan. You have to write it down. This is a voltage of series V1 plus V2 plus V3. And what does that mean by 3 dots here, Ayan?
Means continuous.
Like series, like so on. Okay?
Yeah.
As a number of...
Yeah.
Yes, very good. So did you have written this?
I've written this in my own book.
Very good, very good. We have to move to the step by step. Now we have to talk about the potential difference of the battery is shared across all of the components. Same, like this. If the battery that is coming from the source, that is 12 volt, the voltage that is coming from the source may be 12 volt. Voltage is divided. So maybe one bulb is getting 8 volt, another bulb is getting 4 volt. Maybe this one is getting 6 volt and maybe this one is getting 6 volt. That doesn't matter because the voltage is divided. Maybe both of them are getting same, maybe both are getting them smaller and greater. Did you get the point?
Yes.
Very good. And the next thing is current. Now this is the current. Current ammeter is attached. Ammeter is attached. And the ammeter placed in a series. Same everywhere in the circuit. If the current is coming like a 12 ampere, this is also getting the 12 ampere and this is also getting the 12 ampere. Nothing is divided. Both of them are getting same things. Got it?
Yes.
And the very few things are connected in a series. They are like they have to we can place ammeter anywhere. Like look here, in the previous picture it was here. Now it is here. I can place even here. There is not a specification. We have to follow the rules. We can place ammeter anywhere in the circuit. Got it?
Oh.
Yes. And then because they would get each half of the 12 volts, the current meanwhile is the same everywhere. In the circuit, no matter where you look, we can measure current using an ammeter, which we place in a series, so within a main loop, and we can, because the same current flows through all the components, we can put the ammeter anywhere. For example, instead of putting down here, we could put it up on the one of the sides. It really doesn't matter. So we could also calculate the current by dividing the total potential difference by the total resistance. And the next formula. Now this is the formula of, basically this is the formula of the Ohm's law. Do you know the formula of Ohm's law, na? That resistance is directly proportional to the voltage, and we can say this is a formula V by I, and we can switch this formula. We can make the formula of current V by R. Okay, the current is directly proportional to the voltage and inversely proportional to the resistance. Can you describe the concept of inverse and the direct?
It's indirectly proportional. If something is if one value increases, then the other value will also increase, and inversely proportional. If one value increases, then the other
very good, very good.
And if the other value will increase, then the other one will decrease.
Very good. Same as it is. Very good. So we can say this, that the current I is equal to I1. The current is coming from the source is equal to the current that is going to the first lamp, is same equal to the current going to the second one, and same equal going to the third one. Got it?
Yes.
Very good. So we can say you have to write this thing down also. Then we have to use this formula. Okay?
Okay.
When you're done, let me know.
Done.
Okay. Now the formula is R is equal to V by I. Is it? Now,
yes.
If we are going to talk about the resistance, So resistance, total resistance. So the resistance similar to the potential difference. In that the total resistance is just the sum of individual resistance of each component. This green symbol just means the green symbol, this green symbol. Okay, this green symbol just means sum is total, and you sometimes see it like physics and maths paper. So as an example, let's imagine that this lamp on the left had a resistance of 4. Okay, this is a 4 lamp. Okay, 4 ohms, and the other one had a resistance of 2 ohms. Then the total resistance of our circuit would have to be 4 plus 2, so 6 ohms. Now that we know that the total resistance of our circuit, we can use Ohm's law to calculate the current. By calculating them, we will get the total resistance. So what they're talking about the resistance, when we add the individually resistance of each lamp, you will get the total resistance. Okay, we can say like this: the total resistance is equal to the R1, R2, because as the potential is divided, resistance is also divided. Okay, and R3. So now I have to put the value of R1, R2, R3. What are the value of R1?
R1.
V1 by I, V2 by I. Here I have a question for you. I use 1, 2, 3 with the voltage, but I didn't use the counting with the I. Why?
Can you repeat the question?
And the question is that in the given formula, I use the formula of resistance, and resistance is equal to V by I. But in this formula, I use the V by I, but I use the counting 1, 2, 3 with the resistance, and I also use the counting with the voltage, like voltage 1, voltage 2, voltage 3. But why I just simply wrote I with all of the voltage?
Because current is same.
Very good. Current is same. This is the point. Very good. Current is same. Okay, when you put the values, when you have the value, okay, you will get your answer. You will get the total resistance of any series circuit. Got it?
Yes.
Simply look here. You have the value of this 4 voltage. For example, we have the value of 12 voltage, and then we have a 6 ohm. You will get the current. Okay, 2 ampere. By using this 6 voltage, and this is a current, this is not the current. So you just take an example, 12 voltage is coming to the source, and the resistance is 6 ohm, and by dividing them you will get your current. Got it?
Oh, yes.
We have, and then we know the total resistance by calculating. To give a current of 2 amperes, one thing to be aware of is that ammeter generally have such tiny resistance that we can ignore them in our calculation, which is why we have not included anything for the ammeter, because ammeter just calculate a very tiny current, like just a very minute level of current, very small value. Okay, and for the next thing we need to look at is how they calculate the voltage across a single component in a circuit. We just worked out that the current in the circuit is 2 amperes. And remember that with the current, it doesn't matter whether you're looking at the circuit as a whole or as an individual component. That doesn't matter. Okay? The circuit is a whole or as individual component. The current is always the same. So we can use that current and the resistance of a specific component to find its individual share of the voltage in the circuit. If you have the current, that current will divide its voltage and resistance. You can find voltage and current by just one value of current, voltage and resistance of any circuit by the help of with that current that is coming from the source. For example, this lamp, I think this is in the next example. Okay, for example, this is a right has a resistance of 2 ohm lamp, and the current across it must be 2 amperes. Current must be 2 ampere. Why? Using our Ohm's law equation, again we can see that the potential difference must be 2 amperes multiplied by 2 ohm. So there must be 4 voltage. When you have a current, when you have a voltage, if you want to measure when you have a current, and you have the resistance. You can easily measure the voltage of that circuit by using this formula. Which formula? I is equal to, that is the formula, na? V is equal to IR. You can measure the voltage by putting the current and the resistance value. If you didn't have the current, you can put the voltage and resistance, you will get the current. Okay?
Okay.
So to find the voltage across the other component, we could do the same thing again. So because we know that the total voltage must be the same as the battery, which was 12 volts. We could just do 12 and minus 4 and to find the other lamp and must have the potential difference of 8 volts. This is all the stuff. If you know the formula, you can find anything that is missing in the circuit by using this formula. Got it?
Yes.
Yes. And now this is the thing, like this is a 4 ampere, this is a 12 ampere, 2 ampere, 2 ohm. This is the ohm, this is the value of current, 2 ampere, and this is a value of resistance. Then the voltage will be 4. Voltage will be 4. Got it?
4.
Yes. And then they are using the again formula. Now the next thing is, even though voltmeters are in parallel, still treat the overall circuit as a being series. As a final point, it's good to remember that due to Ohm's law, those components with the greater resistance will always have a higher share of voltage. You have to remember this thing. Those components with the greater resistance will always have a higher share of voltage. Okay?
Okay.
And by looking at this thing, how to calculate the voltage across a single component. For example, they just used a voltage, just round up one lamp. Another lamp will have its own voltage because voltage is divided. तो voltage will be the different. अगर आप एक ही voltage पूरे लगा देंगे इसमें सर्किट में, तो आपको तो उसकी different reading नहीं मिल पाएगी ना. तो आप क्या करेंगे आप?
Then we measure it with voltmeter.
Okay, हम लोग क्या करेंगे? We have to place the voltage with individual lamp. हर एक लैंप को अगर अपनी वोल्टेज मिल रही है, तो क्या आप एक वोल्टेज से वो दोनों लैंप की वोल्टेज फाइंड कर सकते हैं? नहीं कर सकते. ठीक है, तो हम लोग डिफरेंट से भी कर सकते हैं. जैसे कि इस लैंप को 8 वोल्टेज मिल रहा है, उसको कितना मिलेगा? 12 में से 8 माइनस करें, कितना रह जाएगा?
4.
वेरी गुड. तो 4 उसके पास रह गया. ठीक है, ऐसे माइनस करके आप आसानी से निकाल सकते. ओके.
Okay.
Do you have any question, Ayan?
No.
I think everything is clear, is it?
Yeah.
And what we say when everything is clear for us? We say, so far, so good. Is it?
Yeah.
Very
Yeah.
good. What do you think about solving one example?
That would be okay.
That will be okay. Very good. I appreciate that. Now write the example. Consider a series circuit. I will just give you a value right here in the front of a screen. This is a resistance 1, which is 2 ohm. I'm just giving you a data. And this is resistance 2, which is 3 ohm. And this is a resistance 3, Ayan, which is 5 ohm. Is that clear?
Yes.
And all of this is connecting to a battery, which is V total. That is 10 volt. Okay?
Okay.
And you using the Ohm's law, you have to find the current. Find the current.
Okay.
Can you do that?
I guess I can do that.
Very good.